Hi class, today we're going to talk about the remainder theorem, which is the first half of lesson 5-6. This will be page 1. Starting with the standardized test practice problem, it reads, the width of a box is 3 feet less than the length. I'm going to make a note of that to start with. Width equals length minus 3. The height is 4 feet less than the length. So the height is the length minus 4. So therefore the length would be L. And it says that the volume of the box is 36 cubic feet. Find the length of the box. So let me just tell you that this problem, we could make it really complicated or really easy. I would imagine y'all would like it to be really easy. And in that case, what you could do is you could take these values and specifically 2, 3, and 4, plug them in for the length. So if we plugged in a 2 here, our width would be -1. If we plugged in a 2 here, our height would be -2. So that doesn't work. If we plugged in a 3 for the length, 3 minus 3 would be 0. We're not going to have a width of 0. And if we plugged a 3 in here for the length, 3 minus 4 would be -1. So the height can't be -1. Now, we could plug in a 4 and it work here with our width of 1. But if we plug in a 4 here, it gives us a height of 0. And so we can't make a box out of any of these values being the length. So the only reasonable answer is 6. And just to prove that, let's check it. So volume is the length times the width times the height. So if we say that the length is 6, that would mean our width would be 3 and our height would be 2, and that is equal to 36. Which is what it says the volume of the box is equal to. Okay, so on this first page, we're going to talk about 2 kinds of substitution. Synthetic substitution, or another way to say that would be synthetic division. So I don't want you to get the two confused. Synthetic division is when the remainder, when you divide the polynomial f of x by x minus a, is the constant f of a. F of x equals q of x times x minus a plus f of a, where q of x is a polynomial with a degree 1 less than the degree of f of x. Okay. Basically, what I can say is when you have a remainder of some sort, plugging in this value of a into synthetic division, then that tells you that that value is not a divisor. So we're looking for whether or not a certain number is a factor of the polynomial. Let's look at an example so you can see what I'm talking about. Okay. So here is the first example, and we're going to look at 2 different methods. we want to see if f of x is 3x to the fourth plus 2x cubed minus 5x squared plus x minus 2. We want to find f of negative 2. Synthetic substitution or synthetic division says by the remainder theorem, f of negative 2 should be the remainder when you divide the polynomial by x plus 2. So in other words, when we plug this in, a negative 2, the remainder is 8. So that's the value that we get when we plug or divide the polynomial by negative 2. So to refresh you on synthetic division, you take your coefficients, 3, 2, negative 5, 1, negative 2. You bring down the first coefficient under the line, then you multiply. Negative 2 times 3 is negative 6. 2 minus 6 is negative 4. Then we take negative 2 times negative 4, which is 8. Negative 5 plus 8 is 3. Negative 2 times negative 3 is 6. 1 minus 6 is negative 5. And then we take 2 times negative 5 is 10. Negative 2 plus 10 is 8. That is one method, the first method, to find the remainder. The second method is just using direct substitution, meaning taking the polynomial function, and everywhere where there's an x, we replace it with a negative 2. So each one of these, we replace it with a negative 2, and then we simplify. Notice that you get the same answer whether you use method 1, synthetic substitution / we're going to refer to that as division so you don't get confused. Method 2, direct substitution. So let's try one. We want to know, by using synthetic and direct substitution for each function, we want to find f of negative 5. In other words, we want to find the remainder, or what we get when we plug negative 5 into the function. So with the synthetic substitution, we're going to take negative 5 on the outside. And then we're going to divide by the coefficients. We put 4, we put 6, we put negative 7. We drop down an arrow, put a line under the arrow, bring the 4 under the line. And we multiply. Negative 5 times 4 gives us negative 20. We add 6 and negative 20, which is negative 14. We multiply negative 5 and negative 14, which is 70. And we add a negative 70 and a 70, which is 63. So f of negative 5 is 63. We should get the same thing when using direct substitution. So direct substitution would look like this. F of negative 5 equals 4 times negative 5 squared plus 6 times negative 5 minus 7. 4 times 25 minus 30 minus 7. 100 minus 30 minus 7 would be 70 minus 7. So that tells us again that f of negative 5 is 63. So if you're looking for the remainder, You have two methods to find it. Personally, if I had to pick which method I would choose synthetic substitution. I just find it quicker and easier. But on these, we need to practice both and make sure that we get the same answers each time. So let's try another couple of examples. So we're going to use synthetic substitution, or consider that synthetic division. We're finding f of 4 in this function. So we have 4. Bring our coefficients down. 5, negative 4, 2. Line under the, or arrow, drop an arrow under the 5. Put the line, put the 5 under the line, now multiply. 4 times 5 is 20. Negative 4 plus 20 is 16. 4 times 16 is 64. And 2 and 64 is 66. Oh, and I just did that completely wrong. I forgot to mention to y'all. Remember when we did synthetic division, how we had to make sure our powers went down in descending order? Look here how it skips from 3 to 2 to 0. So we're going to have to redo this one. I apologize, especially if you're doing it in pen. But here's how it needs to look. We need to have a 4. Then we go in descending power order, so we have 5, negative 4, 0, 2. Bring down the 5. Multiply. 4 times 5 is 20. Negative 4 plus 20 is 16. 4 times 16 is 64. 0 plus 64 is 64. 64 times 5 is, or 64 times 4, excuse me, is 256. And 2 plus 256 should be 258. Now when we plug in using direct substitution, excuse me, we don't have to fill in a 0 for the missing term. We just plug it in and we should end up with 258. So we do f of 4 equals 5 times 4 cubed minus 4 times 4 squared plus 2, 5 times 64 minus 4 times 16 plus 2. This will give us 320 minus 64 plus 2. Well, 320 minus 260, or I'm sorry, 320 minus 60 is 3, well, of course I can't do it in my head. Why don't I do it this way? Should have been smarter about this to begin with. 320 minus 62, because we can combine the negative 64 plus 2. That gives us 258. So we match. And then on the last examples, we're going to put our negative 3 on the outside. Look at our powers. Are they going descending? Yes. 3, 2, 1, and then a 0. And I don't think we'll go ahead and put that 0. So we've got coefficient of 1, coefficient of negative 6, coefficient of 2, and then a 0. Arrow, bring the 1 underneath the line, multiply negative 3 times 1, which is negative 3, add negative 6 and negative 3, which is negative 9, multiply negative 3 and negative 9, which is 27, add 2 and 27, which is 29, and multiply 29 times a negative 3, which is negative 87. 0 minus 87 is negative 87. All right, last one. This time we'll use direct substitution. So we have f of negative 3 equals negative 3 cubed minus 6 times negative 3 squared plus 2 times negative 3. Negative 3 cubed is negative 27. Then we have minus 6 times 9. And then we have minus 6. Negative 27 minus 54 minus 6. This would be negative 81 minus 6 would also give us negative 87. So we have two ways of finding the remainder: synthetic substitution / division and direct substitution. On the test you'll do both, and you'll know you're right if the answers match. They should always match, but be sure and show your work. Prove your answers. That's it for the page 1. Next time we will look at page 2, which is the factor theorems. So I will see you then, and in the meantime I hope you have a great day.